All right, welcome to the deep dive. Today we're diving headfirst into something seriously cool. How computers are learning to make videos. Not just stringing pictures together, but actually creating moving images from scratch. Kind of like magic, but, with a lot more complicated math behind it.
Definitely a lot of math.
It's getting incredibly advanced, but the real challenge has been getting these AI videos to look smooth and do what we actually tell them to.
Exactly. Think about it. You ask for a dog chasing a ball, and you don't want the dog to suddenly turn into a cat halfway through, right?
Or the ball just vanishes.
Yeah, that seamlessness and control have been the holy grail. And that's why we're looking at something called MAGI-1, developed by Sand AI.
MAGI-1.
It's a new way of thinking about video generation that could really change things.
MAGI-1 sounds like a superhero. So our mission today is to figure out what makes this particular approach so interesting and, how it might actually make our lives easier or our work more efficient, even if your idea of AI is just asking your phone for directions.
Totally. We want to break it down for everyone.
We've got the research paper that spills all the technical beans, and we're here to translate that into something we can all wrap our heads around.
Okay, so the core idea behind MAGI-1 is something they call autoregressive chunk-wise video generation.
Autoregressive chunk-wise.
Okay.
Now let's break that down. Autoregressive is a fancy way of saying it predicts what comes next based on what's already there.
Right.
Think of it like when you're writing a text message and your phone suggests the next word.
Okay, yeah, I get that.
MAGI-1 does the same thing, but with tiny bits of video, which they call chunks.
Okay, so instead of trying to imagine and create a whole video all at once, it's tackling it in bite-sized pieces.
Precisely.
What exactly is one of these chunks? Is it like a little snippet of a movie?
Pretty close.
Yeah.
In their system, a chunk is a short, fixed segment, specifically 24 frames in a row.
24 frames?
Yeah, if you're watching a normal video, that's typically 1 second of footage.
Oh, 1 second, okay. So MAGI-1 is essentially building the video second by second, figuring out what the next second should look like based on the second that just played.
Got it. So it's like building a tower with individual Lego blocks, maybe? Making sure each new block fits nicely on top of the last one.
That's a great analogy.
How does this compare to other video-generating AI we've heard about, like maybe Sora? Are they doing the same thing?
That's a good point of reference. Some other models, like Sora, often use what are called bidirectional denoising models. It's a different approach.
Bidirectional.
Imagine trying to draw a picture by starting with a completely blurry mess and then gradually making it clearer.
Okay.
But you're looking at the entire canvas all at once and trying to refine everything simultaneously. That's a very, very simplified way to think about it.
Wow, that sounds incredibly complicated. So what's the big advantage of MAGI-1's chunk-by-chunk strategy then? Why build with these little 1-second bricks?
Well, the brick analogy is perfect, actually. By generating video in these small sequential chunks, MAGI-1 gets much better temporal consistency.
Temporal consistency, meaning things flow smoothly.
Exactly. Things tend to flow much more naturally in the video because each new second is directly informed by the second before it. No sudden weird jumps, hopefully.
Makes sense.
Also, because it's building the video piece by piece, it's naturally set up for streaming.
So you could start watching sooner.
Yeah, potentially. You could start watching the beginning of a generated video much sooner without waiting for the whole thing to be ready.
That's cool.
And if you want to make a video longer, it's much simpler. You just tell it, okay, generate the next chunk based on what's already there.
So it's a more step-by-step logical process. Okay, I'm tracking now. The paper talks about a transformer-based variational autoencoder, or VAE.
The VAE.
That sounds like something you'd find in a robot's instruction manual. What's the deal with that?
All right, let's unpack the VAE. Imagine trying to send a really long video to a friend with, like, super slow internet.
Yeah, nightmare. Takes forever.
It would take ages, right? The VAE is like a super smart video compression expert. It takes a video and squishes it down into a much smaller, more manageable form. They call this the latent space, while still keeping all the important visual information.
Latent space.
Think of it as the AI creating its own super condensed understanding of what the video's about.
Right.
This makes the whole video generation process much more efficient.
Right. Easier to handle.
Later, it can also unsquish this compressed understanding back into a full video.
So it's like the AI is making a really detailed summary of the video so it's easier to work with. Why the fancy transformer-based part, though? That word pops up everywhere in AI discussions.
It really does. Well, traditionally, these video squishers and unsquishers, VAEs, often use what are called convolutional methods.
Convolutional?
Yeah, imagine processing an image by looking at tiny little squares of pixels at a time, kind of locally.
Okay.
Transformers, on the other hand, are much better at seeing the bigger picture. They can understand how different parts of the video relate to each other, even if they're far apart in time or space.
Ah, so they grasp the context better.
Exactly, and the researchers found that using a transformer-based VAE makes things much faster on modern computer chips, the GPUs designed for AI.
Faster, even if the model is complex.
Yeah, even if the model itself is quite complex, their data actually shows it can decode videos faster than other methods. Table 1 in the paper, if you're curious.
Faster is definitely a plus. So how does this transformer-powered VAE actually do this squishing and unsquishing, the encoding and decoding?
Okay, so in the encoder phase, it takes the 1-second video chunk and uses some clever techniques like imagine filters that move through the video in space and time, along with those transformer blocks we mentioned, to condense it down into that smaller encoded representation.
Okay.
It's like carefully packing all your clothes for a trip into a single organized suitcase. That's the encoding.
Suitcase packing for videos, I like it. And the unpacking.
Right. Then the decoder takes this compressed information, this packed suitcase, and using a sort of reverse process, it essentially unpacks it.
Unsquishes it.
Yeah, unsquishes it, using a technique called pixel shuffle to get the full resolution video frames back. So you arrive at your destination, open the suitcase, and all your clothes are perfectly ready to wear.
Or in this case, the video looks great, hopefully.
Exactly. That's the goal.
Okay, so we've got the video broken down into chunks, efficiently compressed with the VAE suitcase, and then decompressed. What's the next ingredient in MAGI-1's secret sauce?
The next key piece is their autoregressive denoising model.
Denoising, like cleaning up noise.
Exactly. Denoising basically means starting with something messy or unclear and gradually making it cleaner. Think of those old photos that get digitally restored.
Yeah.
MAGI-1 does something similar, but it starts with what's essentially random visual noise for each 1-second video chunk.
Random noise, like TV static. So it's pulling something out of thin air that looks like static, and then somehow turning it into a coherent video.
Pretty much, yeah.
How does it know what it's supposed to be cleaning it to? How does it get from static to, say, a cat? Good question. That's where the autoregressive part comes back into play. Remember how it looks back?
Right, it predicts based on what came before.
Exactly. So as it's cleaning up each 1-second chunk of noise, it's also looking at the chunks it has already cleaned up that came before it.
Ah, okay. It uses the previous clean seconds as a guide.
Precisely. It learns to make each subsequent second clearer while making sure it flows logically from what's already been generated.
Got it.
The researchers talk about something called a noise time step, and during the training process, earlier chunks are intentionally made to be cleaner than later ones at the same stage. It's a bit technical, but it helps the learning.
Okay, so it learns progressively.
Yeah, it's like learning to sculpt by starting with a rough block of clay and gradually refining it, always looking at the parts you've already shaped to guide what you do next.
So it's learning to draw by looking at what it's already drawn and gradually making it better, while also keeping in mind the finishes sections.
Yeah.
That makes sense.
Exactly. They use a training method called flow matching to teach the model how to do this gradual cleanup.
Yeah.
We don't need to get into the weeds on flow matching, but that's the technique.
Okay.
And to speed things up, which is always important, they've implemented something called block causal attention.
Block causal attention.
No.
Sounds important.
It is. Within each 1-second chunk, the model can look at all the individual frames, pay full attention. But when it looks at other chunks, it only looks at the ones that came before.
So it can't peek into the future.
Nope, no cheating. This keeps the video flowing forward in time, naturally, and crucially, it allows them to work on different 1-second chunks somewhat in parallel during training, making the whole process faster.
Working on multiple parts at once sounds like a team of AI artists all contributing to the same video.
Kind of, yeah. That's a good way to picture the efficiency gains.
What other clever tricks does this denoising model have up its sleeve?
They also use something called a parallel attention block, which, as you might guess, handles looking at details within a single frame, spatial attention, and how things change across frames, temporal attention, at the same time.
Doing both at once.
Yeah, another way they boost efficiency, and for the real tech enthusiasts out there, they mention things like QK norm and GQA and sandwich normalization.
Whoa, okay. Jargon alert.
Yeah. Basically, these are fancy techniques to make the AI training process more stable and use less computer memory. Super important for building these really huge, powerful AI models without things breaking or costing a fortune to run.
Right. Keeping the AI stable and affordable makes sense. So it's like a team of meticulous restorers working on different sections of an old film reel. But they can always peek at the already restored parts to make sure their work matches the overall style and flow.
That's a really good analogy for the autoregressive denoising with causal attention.
Okay, we've got the chunking, the compressing VAE, and the autoregressive cleaning process down. Now, how flexible and controllable is this MAGI-1? Could I say, ask it to create a video of a cat riding a skateboard on the web?
Well, while we might not be at the skateboarding lunar feline level just yet, MGI-1 offers a pretty impressive degree of flexibility.
Okay.
Because it processes video in these 1-second chunks, it can handle different tasks quite easily.
Like what?
Like turning a written description into a video text to video, or taking a still image and making it move image to video, or even extending an existing video continuation.
Yeah, and it does all that with the same system?
Yeah, all within the same basic framework. They achieve this by just giving the model different amounts of initial clean information.
How does that work?
Well, for instance, turning an image into a video is like starting the process with the very first frame of the first second already perfectly clear, not noisy.
You give it a clean starting point.
Exactly. And video continuation is like giving it a few seconds of already clean chunks to begin with.
That's a neat trick. So the same core engine can power all these different ways of making video. What about getting really specific with what I want to see? Can I fine-tune what happens in different parts of the video?
This is where it gets really interesting, I think. MAGI-1 has this unique feature called chunk-wise text controllability.
Chunk-wise text controllability.
Yeah, because it generates the video in these 1-second blocks, you can actually provide different text prompts for different parts of the video.
No way. Seriously?
Yeah. So for the first few seconds, you can tell it a fluffy cat sits patiently, and then for the next few seconds, you could change the prompt to suddenly a skateboard rolls into view and the cat jumps on.
You can change the script second by second.
Well, chunk by chunk, which is currently 1 second. But yeah, you can guide the narrative as it unfolds. This allows for incredibly detailed and evolving storylines within a single generated video.
Wow, that sounds like a game changer for anyone who wants to create videos with a specific story in mind.
It really could be.
It's like directing a movie, scene by scene, giving the actors very specific instructions for each moment, rather than just a general overview at the beginning.
That's a perfect analogy. You're the director giving instructions for each chunk.
Imagine the possibilities for making really dynamic and tailored video content. So, okay, let's bring this down to earth. How could this technology actually be used in the real world? How could it make our work or daily lives better, especially for those of us who aren't AI experts?
There are some really exciting possibilities. The real-time streaming video generation aspect is a big one.
The streaming part.
Yeah, because it generates video piece by piece, second by second. It can potentially start showing you the result almost instantly and keep adding to it smoothly.
Okay. What could that enable?
Well, it could lead to new kinds of interactive experiences, maybe. Or even personalized video feeds that adapt in real time based on, well, who knows what input.
Like a video game that's being generated as you play, maybe?
Yeah.
Or a live news report that's being visually created on the fly based on what's being said?
Potentially. Those are the kinds of futuristic ideas it opens up. Then there's video continuation.
Right, making videos longer.
Imagine you have a short video clip, maybe of a special moment from your phone, and you want to make it longer, see what might have happened next.
Yeah.
MGI-1 could potentially generate that continuation, maybe even based on a simple text description like, and then they started laughing, or just by analyzing the existing movement.
Wow.
The research paper shows it's much better at keeping the motion smooth and consistent compared to older methods that just try to predict from the last single frame.
That could be fantastic for editing home movies or for creative projects where you want to build upon existing footage seamlessly.
Absolutely.
What about that chunk-wise text control for work? How might that be useful in a practical sense?
Think about creating training videos or maybe product demonstrations. You could have the video evolve over time. The instructions or the focus of the demonstration could change based on updated text prompts you provide for each second or segment. It gives you a very precise level of control over the narrative flow.
So it's like step 1 shown for 5 seconds with one prompt, then step 2 starts with a new prompt controlling that part of the video.
Exactly that kind of thing. And for creative folks like animators or filmmakers, it could allow for incredibly detailed control over the story and visuals by providing those specific text prompts for each short segment. You get fine-grained artistic direction.
So it's not just about the AI making random cool videos. It's about us having a real director's role in the process, guiding it chunk by chunk.
That's the promise, yeah. More control.
The paper does mention some areas where NDI-1 could still improve, right? It's not perfect yet.
Oh, definitely not. No AI system is. They mention that the current setup is still quite integrated or tightly coupled, as they put it, meaning the same big AI model is responsible for both understanding the high-level instructions, like the text prompts, and creating all the fine visual details, pixel by pixel.
And that's not ideal.
It can sometimes be inefficient and actually limit how much specific control you can have over certain aspects. They suggest that in the future, it might be better to separate these tasks. Like having one part of the AI focus on the overall plan, the high-level story or structure, and another specialized part focus on generating the nitty-gritty visuals based on that plan.
Like having a scriptwriter and a director of photography working separately but coordinating, back on our film analogy.
Precisely. That kind of separation of concerns could lead to more efficiency and maybe even more nuanced control down the line.
Okay. What else are they working on?
Well, they're also working hard on improving the data they use to train the AI. That's always huge in AI.
Garbage in, garbage out, right?
Exactly. So they're focusing on filtering out things like poorly lit videos or videos with too many distracting logos or text overlays. Better, cleaner training data will inevitably lead to better and more reliable video generation.
Makes sense. Better ingredients, better cake.
You got it. And they've also made good progress, they say, in making it possible to run these big AI models efficiently. They mention optimizations for specific powerful computer processors, GPUs like the H100, or even high-end gaming ones like the RTX 4090.
So making it practical to actually use.
Yeah, making real-time use and more cost-effective deployment more feasible. That's crucial for getting it out into the real world.
So it's a journey, but they're definitely making some impressive strides with this chunk-by-chunk idea. Okay, let's try and wrap things up. What are the key things we should remember from our deep dive into MAGI-1 today?
I'd say the main takeaways are, first, MDI-1's innovative method of creating video piece by piece, this autoregressive chunk-wise generation. Second, its smart use of a transformer-based VAE to handle the video data efficiently.
Right, the suitcase packer.
Yeah, exactly. And third, its sophisticated denoising process that builds the video from noise while looking at the past, allowing for that unique chunk-wise text control.
So flexibility and control seem key.
Yeah, this all leads to a system that's surprisingly flexible and offers potentially more granular control than some other approaches, handling various tasks like text-to-video or video extension within one framework.
And what's the big picture here? Why should we, be excited or at least pay attention to what MAGI-1 represents?
Well, the potential impact is pretty huge, I think. From enabling truly live, adaptable video streams and seamless extensions of existing videos to giving creators, whether professionals or just regular people, an unprecedented level of control over the video content they generate.
So new possibilities.
Definitely. MAGI-1, or technologies like it, opens the door to a wide range of new possibilities in our work. Think more engaging presentations, customized training materials, and in our daily lives, like richer personal video experiences, new forms of entertainment, maybe even communication.
It really feels like we're on the verge of a new chapter in how we interact with video, doesn't it?
It does feel that way.
So here's a final thought for you, our listeners, to ponder. As AI video generation gets more advanced and controllable, like MAGI-1 seems to be aiming for, how will this fundamentally change the way we communicate, learn, and, express ourselves in the future? What new kinds of stories and artistic expressions will emerge when creating video becomes this accessible and this adaptable, maybe even controllable second by second?
That's the big question, isn't it? It's going to be absolutely fascinating to see how this technology develops and, more importantly, what we as users actually end up creating with it.
Absolutely. It's one to watch. If you want to explore the world of MAGI-1 further, we've included links where you can see the code, learn about the attention mechanisms, and maybe even try a demo. Go check them out.
Definitely worth a look if you're curious.
Thanks for joining us on this deep dive. Until our next exploration.